Okay, we left off where we're talking about the measuring tape. You need to have an outlet at least every 12 feet. Okay, so you have to make sure that you're covering every 12 foot. Anywhere along the floor within 12 feet. The course code says anywhere along the floor within 6 feet, you have to have an outlet. Okay, so that means if I'm standing in the center, I should be able to reach an outlet within 6 feet to the left and within 6 feet to the right. Well, if I move over a foot to the right, that means I'm gonna go to that outlet because that's the closest one. These are some of the electrical symbols. Again, these are general. These are general. Your ceiling lights, these would be a ceiling light, and the one with a little peg on it would be a wall mounted. Single receptacle, duplex, triplex, that means it's got 3 on it to plug in. They also make a 4, where it has these 3 lines, 240 volt receptacle. Okay, so the reason it's got 2 thick lines on this one and 1 thin line, 2 hots and a neutral. Sometimes they may not have an R or a D, so we need to make sure that we're looking at that. R would stand for a range, D would stand for a dryer. Switch duplex, so it's a duplex. Half of it's duplex, half of it's switch. GFCI, ground fault circuit interrupter. Those are the outlets in your bathroom, kitchen countertop. Split wired, so this one is, I got a switch that controls half that outlet. So I have a switch that controls half the outlet. The other half is always hot, half of it is switched. Special purpose receptacles, so sometimes you'll see this. A lot of times, so some architects will use it. These, with the circle and the thing, is to put in the dishwasher or the disposal. So they'll put it underneath the sink, or they'll put it underneath the sink right next to it, or both of them. And the one will have a DISP, and the other one have a DW. DISP stands for disposal, and DW is for dishwasher. And then some architects will just use the duplex receptacle, period. Floor receptacle, that's when it's in the floor. These are your different switches. A single pole switch, a switch that turns on, it's a light that's controlled by one device. Okay, a double pole switch is something you have, let's say you have 2 lights that you want to turn on with 1 switch, but they're in different areas. Or if you have an air conditioner or a fan that's 240 volts and you want to control it, you need a double pole switch because it's got a hot, and a hot to go out. Okay, single pole only got a hot in and a hot switch leg out. The double pole has 2 hots in and 2 switch legs out. The switch leg is where it goes from the switch to the light. Switched leg. So it's a switched leg of the circuit. A 3-way, it's I can try to control 1 light by 2 switches. So I got 1 light in the room or 2 lights in the room, but I got 2 doorways, so I can control it from both ends. Okay, you can only have 2 3-ways in a circuit. You want more than 2 switches, you want more than 2 locations, now you add a 4-way. If you need a 3rd, 4th, 5th, 100th location, then you add 4 ways. You can only have 2 3-ways. You can add as many 4-ways between as you want. Key operated, you use the key to turn it on and off. Circuit breaker, a circuit breaker, if we're using a circuit breaker to control the switches, if and then it has to be if we're using a circuit breaker to control lights, like in a library, okay, somebody walks over to the panel and they turn on all the breakers. There is no switches. Somebody walks and turns all the panels. Those panels have to be labeled as a switch breaker. Weatherproof circuit breaker. So that's weatherproof. Momentary contact switch is centers off. When I push it up, it makes contact, and then it comes back to the center. I want to turn something off, I turn it off, and it comes back to center. On, comes back to center on its own. Okay, so it's the centers off, momentary. It only makes momentary contact and then breaks momentary contact. Weatherproof switch, it's outside with a cover. The timer switch would be a time clock. Timer switch that you put in a box, not one that sits in a time clock like it's outside for outside lights or the pool or whatever. And then these are panels. Surface mounted, that's outside the wall. Flush mounted, it's inside the wall. T for transformer. Sometimes they use this for the thermostat. Okay, so sometimes they use a circle with a T in it for a thermostat also. Surface mounted fluorescence, so that's outside the wall. Recess mounted fluorescence, that's within the wall, so it's flush with the ceiling, wall, or whatever. A telephone outlet, a wall mounted telephone outlet. That means the telephone's going to be mounted on the wall. So if it's up high, it's a wall mounted telephone. If it's down low, it's a jack where you just plug in your telephone to it. And if it's going to be a wall mounted telephone, that's one that has to have the thing so you can hang the telephone on it. Nowadays, nobody uses wired telephones. A lot of people don't use wired telephones. So, I've seen this symbol also used, and then they put a CABLE. Hear that one? CABLE. Other less common symbols may be used in the drawing. So again, anytime you have something different, go to the print legends. Okay, the prints, the architects, all these can change because an architect is always trying to put in his little special thing. Okay, always go to the legend and what is the architect using on that blueprint? On the blueprint you have in hand, what is the architect using? Pro tip, non-standard symbols on plans. Be aware that plans drawing often do not follow a standard symbol system. Precisely, for example, a plan may use its own custom symbols for light fixtures, or it may indicate a GFCI receptacle with a special receptacle symbol rather than the letters GFCI. Always consult the legend to learn the meaning of each symbol. Okay, here they're using an S and an A, and they go to the legend. S with an A is a switch with a pilot the light when it is off. So what it means, it has a light. So when it's in the off position, that light's on. When it's in the on position, the light's off. What does that do? Well, that allows you to find the switch when the lights are off. So if you have to walk to an area where the light is, you walking in and the light switches on the other side of the room, well, you need to know where the switch is at. So that light allows you to find it. The other is they use it in coolers. So if a cooler does not have a window, you can't tell if the light's on. Or if you got a closet, you can't tell that light's on. So you put a pilot light switch, guess what? If the light's on, that means that the light's off. If the light's off, that means that the light's on. So now you got to go over there and turn the light off. Circuits are represented by curved lines, drawing from one device to another. The lines are curved to prevent any confusion with architectural lines. So your architectural lines are always straight, okay? Here's the panel. This panel is on the inside, and this panel is surface mounted. Here's your receptacle. All receptacles would be flush mounted. They're just showing it on the wall. If it was within the wall, then that means it's flush. This is our meter. A line indicates that grounds are underground. So this would be a lateral run, not an overhead run. Lateral is when it's underground. Overhead is when it's overhead. In every circuit drawn, as it's actually installed, the lines will continue to circuit breaker. So a lot of times, like I was saying, they're not done. The architect, the electrician's the one that draws them. I already showed them in the other prints. I'll open them up in a little while. So the prints are already done. They're only showing you where it's going. Okay, here, this one is showing how the wire is being wired. In residential prints, they don't come like that. Okay, they don't come like this. Commercial prints, they do, because it's engineered. The engineers already, electrical engineer and the architect are engineering the building to make sure everything is balanced on the blueprint. As long as you wire it according to the blueprint, you're okay. In residential, that's up to the electrician wiring. Electrical schedules are the tables that list items such as fixtures, power requirements, panel boards, information, receptacles, and switches. Schedules save print reading time and place information to easily find a location. So a lighting schedule, what type of lights are going in, where they're going. Equipment schedule. An equipment schedule lists large electrical equipment being installed, such as motors, heaters, cooling units, and information provides. In this schedule varies, depends on the specifics. So again, so you will find, you don't usually find a schedule on the equipment. because the architect doesn't know what the heating company is going to use. So the heating company may have a special brand that they use when they're building houses. So they'll specify a 80,000 BTU heater with a 3.5 ton air conditioner. So the company installing it is going to have to put an 85,000 BTU heater with a 3.5 AC compressor outside. Okay, that's all that's what he's bidding on. Okay, so it's your job. What does it need, electrical wise? Because you don't know the name brand, so they're only specifying what type of equipment goes in. Same thing with the range. The range may say, "Oh, we're going to use an 8,000 kW electric range, or a 10,000 kW electric range, 1,000 watts." So it's 10,000 watts, 8,000 watts, 7,000 watts, 6,000 watts, whatever it is. So it's all sized accordingly. Next chapter is when we size the meter. So next chapter, we're going to be talking about sizing this meter with all this equipment that's going in. The panel schedule, residential, guess what? You only got one. Commercial, you may have various, so you'll have different panel schedules. So a lot of times the blueprints, they don't give you a panel schedule because they don't know where you're putting what in. Unless they turn around and they say, okay, this outlet here is going to be circuit 20 on a 20 amp. And this outlet circuit here, these lights is going to be 15 amp circuit 4. Okay, and I got a outlet over here and an outlet over here. It's circuit so-and-so and circuits. Unless they do that, and then they'll give you a panel schedule. They're saying this circuit goes here, this circuit goes here. Again, my 40 plus years, I've never got a blueprint that shows me that. All my blueprints has been wired, and it's wired the way I do it. So here's the lighting fixture schedule. So we're just showing where the different lights, what type of lights are going, where they're going. Notes are added to drawings to convey information that is too difficult or confusing to describe the dimensions or symbols. General notes, those contain information regarding entire installation. So let's say here, they come in there and they put a little cloud around it. And that's a lot of times, that's how they do. They put a little cloud around an area and then they put a note. Instead of being in the general, and then they'll have, go to number 4. Go to E4. So you go and you find number 4 and then you can read the note. Okay, you have the general notes are always on the front page or second page. And then a lot of times notes would be on the actual blueprint, on the floor plan, where the electrical, the plumbing, and everything else is at, and then you'll have a little note. You know, they'll say, okay, fine, we're going to use the pedestal, and it's going to be so far from the wall. So that way the plumber knows that it's not going to be a cabinet, it's going to be a pedestal, and it's going to be over here, not in the corner up against the wall. So your outlet should be accordingly. Pro tip, using the print as a checklist. During the roughing process, use floor plan to keep track of the work that you have completed. For example, after you have finished installing a run, use a highlighter or colored pencil. I never did that. I just wired it, and then when I was done, I knew I started, you know, I'm running from an outlet over, say here's this outlet, here's this outlet, here's my pan lamp, this is a home run, I'm going to there. From there, I'm going to next, to the next, to the next, and from here, I'm going to next, next, to next, whichever it may be. I'm wiring it the way I see it. I'll go to the garage and I'll try to find one of my paper copies, or I got another blueprint, I'll make a copy of it, and then I'll show you how you draw the circuits out, and I'll put it in Schoology. Specifications are documents that list the items of the schedule and the local code requirements not found in the NEC and designated for those responsible for supplying the material. Specifications are specs and are included in the prints to clearly identify what below. So again, specifications, we have a specification, then we have Title 21. Why? The specification tells you what it's doing, and then they'll give you what Title 21 says. Title 21 is all the energy efficient codes, whether it's for building, the building, the type of fixtures in the bathroom, type of electrical fixtures you can use. Now, everything that we put in the house has to be LED. Everything that we put outside has to have either a motion sensor. A lot of times they don't ask for a motion sensor. They say motion sensor, but what they're asking for is a dusk to dawn. So in case I leave the switches on and leave, When the sun comes up, the lights go off. When the sun goes down, the lights come on, even if the switch is on. So we're saving energy. The reason for all of this, everything has to be energy efficient. Everything we install has to be energy efficient, from the bathroom heaters to the bathroom fixtures, light fixtures. I mean, to the fixtures around the house. They all have to be energy efficient. They have to have the energy label on it. Note: center of all receptacles to be 15 inches from the floor. These are some of the notes that I was talking about. Center all switches to be 44 from the floor. All ceiling boxes to be securely mounted with a support bracket. Okay. So, yes, if I'm putting a ceiling fan, I got this sucker. If I'm just using a regular light fixture, this is all I need. Okay. And it has the support bracket. Okay, this is designed as a metal box. The bracket, look how beefy that sucker is compared to this one. This is made for ceiling fans. This is not. And when we measure the switches and we put them in, we're talking about 44 to the center of the box. Center of the box. Okay, the way I do it is I put it, so all center receptacles, all my receptacles, I put them at 17 inches. I marked on the wall 17 inches or 15 inches, whatever it may be. And then I put an arrow going up, okay, to the top. So when I do it is, I'm gonna mark it here. So if I mark it like that and going up, that means to the top of the box, okay? If I got an arrow, that goes to the center of the box. Well, if I got a line like this and I mark it to the bottom, that means to the bottom of the box. I'll put in a quick video that I talk about that and you can learn that, okay? So these receptacles, and this is the architect telling you that these are general information from the code book. Code book says it can't be less than 12 inches to the center of the box. Switches should keep them at no more than 46 to the top of the box. Okay, this is all as a handicap. So you got to keep them at a height where somebody in a wheelchair could reach them. Although prints have list of material to be purchased, specifications often have a similar list. If the two lists do not match, the specifications typically follow. This is basically the print. May be used for multiple projects. So a lot of times, as you get to track housing, what is track housing? Track housing is you got five blueprints, and every fifth house is different. But the thing is, they change them up. Even though this house and 5 houses down are exactly the same, they change the outside fixtures. So they may give you a general note for everything, so you have to turn around and find for each one. Electrical codes and safety agencies. There are many different types of different methods of providing electricity to homes. You will learn with various types of conductors, devices, and procedures available to use. Well, all those that cannot be used, therefore selecting anything. What we use is a National Electric Code Book. This is our electrician's Bible. California is under 2017. Everything we do is in here. They don't give you specific on how to do it. They just give you a general idea, and they give you the minimal requirements that you have to look at to make sure you get this done. Electricians, builders, designers, and inspectors routinely refer to the NEC for any of all matters involving electrical design and installation. Therefore, it is imperative that apprentices obtain and study the latest edition of the NEC. Introductory codes. So the Article 90, 110 serve as the introduction to the remainder of the NEC. Article 90 explains that it is not covered in the code. Article 100 provides the essential definitions used throughout the NEC, and constant terminology is essential to preventing confusion and interpretation. Article 110 is a roadmap of the codes, where you will find general requirements for electrical installations. And Article 110 is just giving you a general thing, what you need to look at before you start going further down. And then they can't tell you how to install a light. You know, they can tell you, all it turns around and says, you know what, when you buy a light, to install it in a light, okay, follow manufacturer's installation. to the code. How do you install something? You install it according to manufacturer's installation requirements. So the code just gives you one sentence. It says you install it according to manufacturer's instructions. Although NEC itself has no legal bias and other mandatory under local or state laws, in such cases become a legal document. The authority having jurisdiction is a person or group of persons responsible for approving the equipment, material, and procedures used in electrical installation. The AHJ is in most cities and towns and counties. So a lot of the authorities having jurisdictions, a lot of the local inspectors, what do? The state of California adopted the National Electric Code, but they don't call it the National Electric Code. They call it California Code. So what they do is they adopt the codes that are in here, and then they just change it to California codes. Code enforcement, almost every state, region, or locality has some sort of local code. So again, you have to find your local code. There's codes at the city. The code book is a general and gives you the minimal requirements. The NEC gives you the minimal requirements needed. Okay, a local agency can come in and make them more stiffer. They can't make them less lenient, but they can make it more stiff. So you always have to be aware of what did the local or the state change from the NEC, and have to be aware of that. All that information can be obtained from your local jurisdiction, because that's the person that you're gonna go to, not by the state. You're gonna go by your local AHJ. So they're the ones that do it. He's the one that has the last call. Guess what? The inspector, it's his job to interpret what the code book says. You can sit there and argue till you're blue in the face or maroon red like on my t-shirt. I've done it. And inspector turns around, I've got inspectors so mad. They turn around, well, I'm the inspector, I got the authority. And this is my interpretation of what's off. Inspections and permits and licensing. In most areas, the AHJ requires a permit for any significant electrical installation remodeling. It may also require that the work be performed by a licensed electrician. The local utility company also may require that jobs are permitted and that the work is being done under the supervision of a licensed electrician. So again, when you pull a permit out here in California, they allow you to put a homeowner's permit, except for solar. So as long as the work is being done by a qualified electrician, you shouldn't have a problem, even if the homeowner pulls it out. These are some of the testing agencies. So the nationally recognized testing, UA, UL, Underwriter Laboratory, CSA Group, Interlake, formerly ITL, Curtis Elizabeth. So the CSA is a Canadian. Think Green Renewables and the NEC. The NEC is keeping steps with advancements in renewable energy, including important update codes required and definitions, both the 2014, 17, and 20 edition. The bulk of the code standards and solar electric installations are Article 690. You have to also go in systems in Article 691, large scale photovoltaic systems, electric power production facilities. Article 225, Article 230, and this is for breakers and stuff, services. And then 705, it's for that's when you have an external source coming in. So you have the utility, but then you also have an external source. So it's a code that covers it. You have to make sure both. Article 94, wind. 710, standalone systems. So standalone system is when you're out in the boonies and there is no electricity and you're putting in a system in to control your own electric. Summary prints are official copies of construction drawings that often referred to. They provide product installation details. Electricians may refer to the foundation, framing, plumbing, and other prints to help guide installation of electrical. Electrical equipment is shown on the prints and the standard symbols. Okay, so here's your summary. These are the questions, apply and analyze and everything. Those are going to be your part of your homework. Stop sharing this real quick. I forgot to sign in. All right, you're going to have two jobs. One is going to be the master blueprint floor, and the other one is the kitchen blueprints. Let me open this one up. So there's your bedroom floor. Here's the closet with two doors. And then here's the bathroom, bathtub, shower, toilet, and a double sink. Okay. Your job is, you can draw this on a piece of paper, take a picture of it, and email it to me. It says you can print or just fill the, draw the floor plan, fill in with the switches and receptacles and luminaires, look at the sample blueprint and symbols to complete this assignment. Take pictures and upload or email it to me. Okay, so you're gonna look at this, and this is the master bedroom with a master closet and a bathroom. That's one job. The other job is the kitchen, and you can do the same thing. So here's my refrigerator, here's my dishwasher. I needed a disposal down here, and here's the stove. Along the kitchen, code says anywhere along the floor, everywhere 2 feet is, I have to have a receptacle. So I can't go more than 4 feet without a receptacle. So with that said, is one is I need a switch. I would need a light over the sink with a switch here, and I would need a switch on one of the two sides, it doesn't matter. And then I need a switch to switch the disposal. And then I need a special purpose outlet for the dishwasher. Obviously, I'm gonna need more than one receptacle on this one and there. This is my refrigerator, the one here. And then because this is an open area, this is more than 2 feet. And I talked about it yesterday, if I got a wall more than 2 feet, I need a receptacle. So somewhere along here, I'm gonna need a receptacle. Okay. Your job is to make those two drawings. You can either look at this drawing or you can look at the other one, the one I gave you the homework for the lights. This is your work for tomorrow, Tuesday, right, for today's Sunday, sorry, Tuesday. So you can look at this one. You see how it's got the heating, insulation, carpet, plumbing notes, all your Title 21 and different codes that pertain to whatever's going. Elevations. So an elevation would be your front, back, both sides. So there's the front, one side, the other side, the back side, and then the other side. Okay, this is a floor plan that the carpenter would use. This is giving them dimensions. All the dimensions are on it. Okay, all the dimensions, so he knows where the window's going. He knows how big the room is. Okay, that's one floor. Here's another floor. And this is a section. It's a side view. So it's a side view of the house. So now you know the elevations of the house. You've got the garage and the basement or whatever. You got one level, other level, and then up on top. And this is whatever the carpenter needs. And this is all for the foundation people. The concrete that needs to be pulled in. The windows, type of windows. Securing of the floor, securing of the building to the concrete. All what the carpenter uses. How did the architect, the engineer, the steps. Okay. Foundation guy. So the foundation guys would use this blueprint. This is all concrete. These are your rafters or floor joists. Same thing. And these are your rafters up on top levels. Oh no, here's your top level. I'm sorry. These are your roof, your rafters up on the roof. Wind loads, snow loads, and everything else. Okay, so this is your ground level. Okay, it's got lights down at the ground level. These are lights. There they are right here. Okay, so look at these blueprints, you get an idea. So this one here's the kitchen. You can see where they're showing. There's a sink, there's a light. Again, you're doing the blueprints wherever you want. So this one's got 1, 2, 3 lights there, and it's got lights around here. What type of lights? I don't know. They're over here. All the lights are recessed. All the lights here are recessed. Okay. Got outlets. It's got the refrigerator, switches for the lights, dishwasher. Okay. And here's a master bedroom, master suite. So there's the switches, lights. Okay, so you can use the blueprints here. Here's a walk-in closet. So here's the door. Here's a walk-in closet, and here's a master bath. The door starts here for the master area. Okay, so this is his and hers. And here's a shower, master bath, toilet, a bathtub. This is a shower. That's a bathtub. And here's a toilet. And then here's a double sink. Okay. So you can use this. Or you can use a simple layout. And that's the one you were working with first. And again, you do it whichever way you do. Whichever way you see the blueprint, the way you got it in your mind, that's the way you can do it. Okay, here's the kitchen. So there's a fridge. There's a dishwasher. There's a switch for the light. There's a switch for the receptacle. We've got our receptacles. Okay. This one has a countertop. Don't we have a countertop? What do we got at the end here? These are pendant lights. These are lights that come down. This would be a recess. One of the switches would be for the light, and then one of the switches would be for the disposal. They're not showing the disposal, but it's there. That's why it's got two switches. Okay. One would be a light, and one would be disposal. Okay, and you go to the top level. Here's a bedroom. This one only has one bathroom out in the hall, but you can use the example around here. Okay. It's got a closet. It's got a switch for light for the closet. Just remember, your closet has two doors on it. And so, and then you can also use the legends here. You can use the legends from the other one. You can use the legends in the book. Whichever way you want to do it. All right. This is your homework. Watch a video. And then do the two drawings. All right. That's and then I see you all Wednesday night. So I'm giving you time to, so this is your work you're going to do on Tuesday. If you have any questions, I'll be on Schoology from 9 to 11 in the morning and from 6 to 8 in the afternoon, Tuesday afternoon. All right? Y'all have a good one.